in statistics 2, we said you have to look at what we call mean using assumed mean, variance, standard deviation, and then you have to draw an ogive. Then from the ogive, you're supposed to calculate the median, upper quartile, lower quartile, semi-interquartile range, and such. So let's again use a question to understand the whole thing. So a question like this, let's say you're given data, you're given a data like this. You're given, again, let me use mass this time. You're having mass and you have frequency. Now, since you have that, and then let's again use, again, 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79. Let's say now 80 to 89. Again, let's use, let's say 6, 8, 10, 13, 14, and then 9, 7, 4, 2. So that is the frequency. So now, from this data, we are supposed to calculate one, mean, using assumed mean. 2, you're supposed to look for variance. Number 3, standard deviation. And part B, we have to draw an ogive. And from the ogive, you're supposed to calculate median. You're supposed to calculate interquartile range, and maybe you're supposed to calculate, let's say, 7th decile, example, 7th decile, and you're supposed to calculate, we have the 1, 2, 3, and then number 4, let's say you're supposed to calculate the 60th percentile. So you're supposed to look for all that. So the table for statistics 2 is quite different from that of statistics 1, because you have to have the mass, X, F, CF, then you have D, which is the difference between midpoint and assumed mean. Then we have FD, we have D squared and FD squared. So you have all those values that you have to put. So in this case, you're having let's look at this question now in this way. So in this case, let's be given assumed mean be equal to 50. That assumed mean you'll be given. They can ask you using assumed mean of 50, using assumed mean of 40, and such. So the assumed mean given is given. Assumed mean is given in the question. So you have 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to, no, it goes up to 89. So again, let's look at how do we do this now. So we're having the midpoints again, just like in statistics 1. The midpoints are the same, 14.5, 24.5, 34.5, 44.5, 54.5, 64.5, 74.5, 84.5. The frequency you have 6, 8, 10, 13, 14, 9, 7, 4, and 2. Cumulative frequency, we add 6 plus 4, that is 6 plus 8, you get 14, plus 10, 24. This will give you, that is 7. That 7 plus 14, that is 1 and 51. and then you get 60, 67, that is 71, then 73. So when you add all this, you get 73. That is your CF. Then D, it is X minus A. X minus the midpoint. That is the midpoint minus the assumed mean. So 4.5 minus 50, you get negative 45.5. 14.5 minus 50, you get negative 35.5. This will give you negative 25.5. This will give you minus 15.5. This is minus 5.5. And then 54.5 minus 50 is going to give you positive 4.5, 14.5, 24.5, and 34.5. So you have the D. Then FD, you take this D divided by frequency. So you have 45.5 multiply by 6, you're going to get minus 273. Then 35.5 times 8, you're going to get negative 284. 25.5 times 10, going to get you negative 255. Then you have 15.5, you multiply by 13, it's going to give you negative 201.5. Then 5.5 times 14 is going to give you negative 77. Then 4.5 times 9, 4.5 times 9 will give you 40.5. Then 14.5 times 7 will give you 101.5. Then 24.5 times 4 is giving you 98. Then you have 34.5 times 2, which gives you 69. Now, you come to D squared. Now, D squared, you take D squared. So, if you use the calculator directly, that is negative 45.5 squared. The answer will give you a negative. But we assume the negative and use a positive because a negative times a negative is equals to a positive. So, therefore, 45.5 squared will give you 2070.25, 2070.25. So then you multiply by F. So multiply by 6. It gives you 1242.1.5. So you have to do that. Then you come 35.5 squared. It gives you 1260.25, 1260.25. Multiply by 8. It gives you 1008.2. There is no point, 1008.2. Then you have 25.5 squared, giving you 650.25. 650.25 multiply by 10, giving you 6502.5. Then you have 15.5 squared, which gives you to 40.25, multiply by 13, it gives you 3123.25. Then you have 5.5 squared, of course, gives you 30.25, multiply that by 14, it gives you 423.5. Then you have 4.5 squared, of course, gives you 20.25, multiply by 9 is giving you 182.25. Then you got 24.5 squared, gives you 600.25, multiply by 7, it gives you 4201.75. Then you have, you have 14.5 squared, it gives you 210.25, multiply by 7, it gives you 1471.75. Then you have 24.5 squared, gives you 600. 24.25 multiplied by 4, which gives you 24.01. Then you have 34.5 squared, which gives you 1190.25 times 2, which gives you 2380.5. So now, that is the distribution table for that data. Now, let's start with mean. To get mean using assumed mean, we say assumed mean plus sigma fd divided by sigma f. So you have to look for sigma fd. So you have to come here, sigma fd. Our sigma fd, you get negative 273 minus 283 minus 255 minus 201.5 minus 77 plus 40.5 plus 101.5 plus 98 plus 69. That gives you negative 780.5. So to get the to get the mean using assumed mean, our assumed mean was 50. So plus minus 780.5 divided by sigma f, which is 73. You add all this, give you 73. So this will give you 50 minus, because plus and minus becomes negative, divided by 73. You get 10.7. So therefore, the answer for this question is going to give you 50 minus 10.7. It gives you 39.3. So that becomes our mean using assumed mean of 50. Then how do we get variance? Variance is given by sigma fd squared over sigma f minus sigma fd over sigma f bracket squared. So in this case, you're going to have, you have to add now sigma fd squared. Now, sigma fd squared in this case, we are having 12,421.5, 12,421.5, you add 10,008.2, you add 65,02.5, you add 3123.25, you add 423.5, you add 182.5, you add 1471.75, you add 2401, you add 2380.5, which gives you 38,988.5. So you have sigma f d squared. So to get variance, you will take 38,988.5 divided by 73 minus 780.5 divided by 73 bracket squared. So this will give you, divide by 73, it will give you 534.1. Then this other one, 780.5, divide by 73, then squared, you're going to get 114.3. So you take 534.1 minus 114.3. The answer is 419.8. So that is our variance. Then part 3, you're looking for standard deviation. Now, standard deviation is equal to the square root of variance. Standard deviation is equal to the square root of variance. So you take the square root of 419.8. So the square root of 419.8 will give you 20.5. So that is the first part of the statistics too. So you have the mean using assumed mean, A plus sigma FD over sigma F, variance, sigma FD squared over sigma F minus sigma FD over sigma F bracket squared. Then standard deviation is equal to the square root of the variance. So this is now the first part of statistics 2, where you have to calculate that. Then the second part is that of the ogive, drawing an ogive. So again, when you're drawing an ogive using the same data, we are going to use only the marks X, F, and CF. So we don't need this one. We don't need the D. We don't need the FD. We don't need D squared or FD squared when we're drawing the graph. So we only concentrate with only this other part. So we have to get rid of that. We have to get rid of that. Then let us now look at how do you draw an ogive. You need the y-axis and the x-axis. Now, just like the histogram, the x-axis must have the upper limits. But now on the y-axis, we have the cumulative frequency. The difference is in histogram, we use frequency, but in an ogive, we are using cumulative frequency. So in this case, we start with 9.5. Then you have 19.5, 29.5, 39.5, you have 49.5, 59.5, 69.5, 79.5, 89.5. So you have that. So on the y-axis, the highest frequency, the highest cumulative frequency is 73. So again, you can use, let's say 10, 20, 30, 40, 50, 60, 70, and let's say 80. So we have that. So now, when you're plotting the points, that when you're having the points, you have to look at 9 goes with 6. So 6, let's assume 6 is around there. Then our second one, 19, goes with 14. So 14 just above 10. Then you have 24 just above that, so 24. Then you have 30, that is 39.5, you go to 37. Then 49, that one takes you to 51. 51. Then you have the other one that gives you from 51 to 60. From 60, you have 67. Then from 67, you have 71. Then lastly, you have 73. So our ogive assumes a sigmoid curve to look like that. So you have the points. You have those points. So that is our ogive. So that is how you draw an ogive, having the cumulative frequency and the upper limit. So now, using this ogive, we can be able to calculate the median. We can determine the median using the graph. So in this case, what you're supposed to do, you take median is equal to a half times 73. So that will give you 36.5. If you take that 6.5, so if you take 73 divided by 2, which gives you that is 36.5. You come to your y-axis on the cumulative frequency and check where you have that 6.5. So if you have that 6.5 as there, so that is the point where that 6.5 is, you have to create a dotted line until you come in contact with the curve. After you get the curve, you go down and write the value that is down here. So assuming the value that I have here, by assumption, because I'm using the board, by assumption, maybe the value that you got here is 40.1, example 40, let's say 40.5. That is the value of the median. Now, so the examiner checks whether you have this, then on the graph it must be shown that you try to get that. You also did that, so this work must be shown on your graph. Number 2, we have to get what we call upper quartile. So upper quartile, you take 3/4 times 73. So if you take 3/4, that is 3/4 of 73, 3/4, 3 times 73 divided by 4, that will give 54.75. So you have 54.75. So 54.75, using your graph again, you come to where you have 54.75, assuming that is the point where you have it. Then you have to go parallel to that. Then you come down here and write that value. So assuming that I got this value here as, let's say, according to a value there, let's say I got 52.5. I'm assuming, this is an assumption. So if I got 52.5, then that's the upper limit, then I can get the lower limit, lower quartile. Lower quartile is equal to 1/4 times 73. So if you take 73 divided by 4, you'll get 18.25. So again, you'll come to where you have 18.25, then read the value down there after that. So this value you have here, let's say that one is 21.5. That is our lower limit. So to get the interquartile range is equal to upper quartile minus lower quartile. So that will give you 52.5 minus 21.5. So if you take 52.5 minus 21.5, you'll get 31. So that is how you get the interquartile range. You can also be asked to calculate semi-interquartile range. Semi-interquartile range is equal to interquartile range divided by 2. Interquartile range divided by what? Divided by 2. So interquartile range is going to give us that 1 divided by 2, which will give you 15.5. So that becomes our semi-interquartile range. Then we are going to look at now, how do you look for deciles and percentiles? So in this question, you're being told to look for 7th decile. So 7th decile, again, what you're supposed to do, you have to take 7/10 times 73. 7/10 times what? 73. So 7 times 73 divided by 10. It will give you 51.1. So again, you have to look 51.1 on your graph. So you come to where you have 51.1, you get that value, and then you read that value. Let's say that value is 50. Let's say that value is giving you 50.5. So that is how you're supposed to get the decile. The decile means over 10. So 7/10 times 73, then you use the graph to get that value at the end there. Then you have the percentile. The percentile means over 100. So 60th percentiles means you take 60/100 times 73. Again, so if you take 60 divide by 100 times 73, you get 43.8. So 43.8 will give you, you come to where you have 43.8, from the graph, 43.8. 43.8, let's say you get there, then you read this value that you're having here. Let's say that will be 35.5, that's assumption, that 5.5. So the most important part of this work is not necessarily how to come up with those answers there. It's about how do you work it out. The concept behind it. You have to understand the concept. When I'm being asked to calculate the median, what am I supposed to do? You take a half times the sigma f, that is what I've done, all these things are the ones that you have to understand. You must have the concept for you to be able to work it out. And that marks the end of statistics 1 and statistics 2.